that allows us to move through, touch, feel, and experience the world around us. It is within this vessel we live our lives, and for the most part, we take it for granted. It isn't until something goes wrong that we begin to realize how delicate this vessel can actually be. On the outside, the body's makeup seems quite simple. Skin, muscle, hair and teeth, bones, organs and blood. But what if we were to dive deeper? We would see that the body is indeed an amalgam of complex systems that, like the inner workings of a clock, all tick along in perfect timing. So perfect, in fact, that it's truly a wonder mistakes don't happen more often. Like the engine of a car or a computer's operating system, scientists can now diagnose and oftentimes fix malfunctions on a cellular level. Through years of research and countless hours of study, they have begun to unravel the mysteries of ALS. So how exactly does a mutation such as C9orf72 affect the body? To find out, we go to Dr. Timothy Miller, an assistant professor of neurology at Washington University in St. Louis.
So to understand how our treatment for ALS works, you first need to understand what some people call one of the central dogmas of biology, which is there's DNA, RNA, and then protein. And the DNA, you can think of it like a blueprint. Let's say, for example, building a house. It's kind of the prints that say the instructions of how to build a house. That's your DNA. And that's in every cell in your body. It tells you how to make a human being and how to continue to help that human being function. That's the DNA. The DNA is cumbersome. It's written in a code that's hard to understand. It gets rewritten into this stuff called RNA. RNA is a better set of instructions. The RNA is the instructions for how to make stuff, like the proteins, for example. Think of the proteins as the wires, the bricks, the pipes that are part of the house. So now you've got a genetic mistake. The mistake's in the DNA. It's way up top. It's in that set of instructions. But then it gets rewritten and that mistake goes on down to the RNA. Oh no, now there's a mistake in my instructions. When you have a mistake in the instructions, the stuff you're making on the other end, the pipes, the bricks, the carpet for the house, all of that stuff has now got a mistake in it too, because there's a mistake in the instructions. And actually, it's like a house. It goes on for a while, it's fine. 20 years, 30 years, 40 years, it's fine. But then you realize that there's a problem. And that problem, whether it be in a brick, or that problem is in the pipes or in the wiring, there's a problem because of that mistake that was in the instructions. And that problem got written in long ago, and now it's there. And then that problem begins to take the house down. That one mistake is something that begins to crumble, and then the whole house begins to fall.
So how can we eliminate or reduce the C9 mutation from the body? One way could be to intercept and destroy the genetic instructions that the body uses to make that protein. These instructions, called messenger RNA or mRNA, are copied directly from the DNA found in every cell. DNA is that familiar double helix, shaped like a twisted ladder. The rungs of the ladder are made of 4 different types of chemical letters, which make up the code of life. The order of the chemicals in the C9 gene dictates the unique instructions the body uses to make the C9 protein. mRNA is like the photocopy of a segment of DNA, containing the same chemical information found in the DNA. Instead of a twisted ladder, mRNA looks like half a ladder, which has been split right down the middle of each rung. Its single chain of chemical rungs matches 1/2 of an unwound DNA helix. Once copied from the DNA, the messenger RNA molecule gets translated into protein. Scientists led by Dr. Miller are preparing for a clinical trial of a treatment to seek out and destroy C9orf72 mRNA, so that it can no longer provide the instructions for making the toxic C9 protein leading to ALS. Miller and his research team at Washington University in St. Louis have designed and manufactured tiny synthetic snippets of RNA molecules called antisense oligonucleotides, or antisense oligos for short. These oligos consist of chains of just 20 different chemical units arranged so they will specifically match up to block information of mutations such as C9orf72.
So if we can help erase that part in the RNA where that mistake was written in, if we can help erase that, we think that the body will then slowly recover and can actually heal, as it does in many other processes where the mistakes that are made, the problems that occur, are in fact cleaned up and made better. C9ID and the process of identifying these patients ahead of time can really cut the process down in terms of when we have a drug ready, we're ready to launch the clinical trial. We learned a lot from the SOD1 experience in terms of how to move this forward more quickly, and that's something that we want to do by having the patient groups ready to go for the next clinical trial.